Hello, welcome back to a new episode on building Funq, a DI container using TDD. And on the previous screencast, we basically cleaned up the Fluent API. We have all the features that we planned to have so far, including container hierarchies, disposing containers and disposing the instances created from them, and also the support for reusing instances across a hierarchy or within a container. One thing that is missing so far, which is really handy in a DI container, is the ability to specify an initialization routine that would be called when the object is being initialized in a container or otherwise. Basically, the use case is, let's say you have an object that implements iRunnable, and basically whenever the instance is created, you want to call that run or start or initialize method. So we're going to go and add that behavior, and in order to do that, we'll do a unit test first, as usual. So we can get rid of this test from the previous one, Fluent API. We was just showcasing how the API works. So let's go and create a new interface here, initializable, let's say, and let's say that this guy exposes initialized method, and let's create the corresponding class. And what we want to do here is basically check how many times we are being called. Essentially because we want to be called only once, and that's at the time when the object is constructed. Okay, because this is an initializer for the object. It's not something that we want to get called more than once. So initialize calls plus plus. So let's go and create a test. What do we want the API to look like? Initialize is called when instance is created. Let's register the initializable object, and because we were having the Fluent API all over the place, let's go and add something like initialized by, and let's make it so that we can pass a function here. It wouldn't be a function; it would be an action, actually. And what would we need? What would we need for the initialization here? Well, we will need the instance that has been created, right? So that we can call initialize on it. Okay. We might also want to call start, or maybe hook up events and whatnot. Something that would also be useful here is if part of the initialization also means passing more objects here, then we may need to get access to the container. So it could be a good idea to basically have this as an action that receives the container and the instance. Okay, and let's get the container. And now let's do the initializable one. It's going to be container.resolve initializable, and the var I2 is going to be initializable, and let's specify that this is reused at the container level, so that we get the same instance twice. That means the initializer would be called only once. And let's now make the assertion that first that they are the same, this is part of how the container works, not precisely this test, so we can probably do away with that. And what we want to assert, let's keep it anyways, is that are equal 1 initialize calls. So we should have been called only once on the initializer. Okay. Now, because we have our Fluent interface now, we'll have to go first to our syntax and think on where we want to put that initialization code. I would say this is something that can be done at any point too, right? So it's pretty much like named in that regard. Actually, register and dot initialized with, probably the initialization is as important as the registration itself, because it's also a function. So so it's another lambda that you pass in. So we can see from here that we have the delayed here. It would be nice if the second one would be the initialize and the rest would come later. Yeah, I think that's better. So so the first thing you could do when you do register is either initialize or give it a name. So that means that we would need to have a new member initialized, now the initialized method needs to be strong typed to the type of the service that we are registering, right? Because we need the action to be so if we do it this way, let's go step by step. Let's make this as an iFluent interface, and let's put the attribute there. So what would this return? Well, it would have to have the new one. We need one more interface, which is I named reused owned, which is iFluent interface I named and I reuse owned. Okay, and that's what we would return from here. So I named reuse owned initialized by, and now here comes the tricky part. So this has to be an action of the container and the type of the service, because we need that to be strong typed. So it's going to be type of the service initializer. So we need that type over here. Okay, and now the iRegistration can do either the iInitialized and now we need a T. So we will need another registration with the T. So let's keep this one here with the I named and I reuse owned, and yep, and let's add a new one, which is the one with the T. Actually, let's add some more space here. This is getting a little bit too type. I registration of T service, and this is gonna expose I initialized of T service. So I initialize, but it will also expose all the things that the registration exposes. So it will actually inherit from my registration. Okay? So so that's the first thing, making up the Funq part. Now we need to go and implement this I registration of T service on the registration object. So what we return from here now would need to be an I registration of a T service. Okay, and now I need to basically have another registration which contains the generic type. Now here comes the trick. If I add the T here, T service, then I will no longer be able to work on registrations in a generic way. So my code here in the builder, for example, when it has a list of registration, it cannot have an empty T there, you know, it cannot do that, right? So it will have to be the T of something, and in order to still work in a generic fashion with the registrations, I will basically go and create another one and keep this as a base class for that. So I will make this abstract, so and I will create another one which will be the registration with the generic T. And the registration.generic is going to be the internal tool. This is the one that will have the T service and will inherit from the other one. Let's just copy over the constructor there and call the base. And so what I need to do here is, so registration already implements I registration. What I need to add is the I registration of T service. And this will give me the member that is missing. I can return myself. And I named reused owned, of course. Now registration needs to the I registration needs to also implement I named reused owned, so I can return myself. So now I have the action initializer, and I know that it's going to be strong typed because that's what the API allows for. But just as we did before with the factory, which is an object, so that we can treat it in a generic way, I can do the same thing here and say initializer and basically provide the can I do internal set here? Yes, I guess I can. And basically from here I would do initializer equals initializer. Okay, so now that I have this doesn't compile. Why? Because the setter must be more restrictive than the property or indexer initializer. Never mind, let's do it like this. Oh, instead initializer and let's have the registration generic called set initializer, and that's it. Okay, cannot create an instance of an abstract or base class registration, so here we need to create the registration, right? For the type, okay, it compiles. Now, of course, it compiles. Now we got our Fluent API there. Now we can go name, we can go reuse within, but if we don't do the initialize first, then we cannot do it anymore. That's good. Gives consistency to our API. And let's run this, and of course nothing will happen because we are not calling the initializer. So, what would be the place to call the initializer? And I think the place to call the initializer is the place where we are actually creating the instances. So let's go to the container. Let's go to our create instance method. And from here, we can say if the entry dot initializer, and we don't have the initializer on the service entry, just like we did before, every time we added something on the Fluent API, we have to push that also to the entry. So let's go to the service entry here, and let's add one more object here, which would be the initializer. Good. When we clone, we do clone the initializer. For the service entry fixture, I can probably and should probably initializer equals the object, and basically make sure that I'm doing the copying. Yep. So I have the value here and the key. Now when we create the on the container builder, when we are creating the key, the entry, sorry, here in addition to the factory, the scope, and the container, we will set up the initializer, registration.initializer. And now, finally, back here in the container, we can check if the initializer is not null, then we can call it, and we know that it's going to be an action of type container tservice, and we can cast the entry initializer to that and do an invoke with the container and the instance. Let's go back to the test, run, and it works. So we have an initializer that is called whenever the instance is created. And let's see what else we can do here. Yep, I think if you have more features that you would like to add, I think that this is pretty much what you would need from a DI container. On the initializer, you could do a whole bunch of things. One of the things that that somebody asked me, and I forgot to mention, is that this seems like a container that does constructor dependency injection, and that's not actually the case, because we are not dealing with constructors or anything. We are just invoking functions, right? So you could very well do inject property dependencies. How would you do that? Well, let's say you have your foo here has a property bar, right? Oh, it's private setter, so let's make it public, and so they can just use the same class. And I'm gonna create it without the with the parameterless constructor. So what I can do is bar builder builder.register, and do the new foo, and because we have the full object initializer syntax here from C#, we can do container resolve iBar right there. Okay, so we don't need to have anything special in order to do property setter injection and constructor injection. We can actually mix and match. We can do the two. So So this makes up for a very, very flexible approach, I think. And the other is, of course, in the initialize, I could also do more injection if I wanted, right? So I could basically have my own delegate here and do more stuff here. Like, well, iFoo doesn't implement anything, but if it did, I could invoke members here and do all sort of stuff. So I think the flexibility is very high, and the performance is very good because all we are doing is casting. So the only cost that we are incurring on the framework, as opposed to doing the new yourself, is basically a dictionary lookup for the service entry, and then a cast of the function to the concrete type. So that's the only thing. Even if you're passing constructor arguments here, the support that we added before, like for example passing a string, and then when you resolve passing the string. Even in that case, we are not doing any kind of reflection at all. It's all at most a cast away from just invoking the actual function. So I hope you enjoyed the journey. I'm going to be publishing this in Google Code. The URL is going to be code.google.com/p/funq. It's already public there. I have been checking in the code in there, and this is going to be released for .NET, for Compact Framework, for Silverlight, and I hope to do that for Mono also. So thanks for joining me on this, and any feedback, please either send me an email or on my blog or on the Google Code project. Thanks.